We're delighted to welcome you to the Darbar Hall at the Diggi Palace, Jaipur, here at the 14th Jaipur Literature Festival protected by Dettol. It's our pleasure to present today of Nagarjuna, Sunyata and Stardust, Carlo Rovelli and Priyamvada Natarajan in conversation. This session is brought to you in partnership with the University of York. We are all made up of the same stardust, of which all things are made, says the acclaimed Italian physicist and writer Carlo Rovelli, drawing inspiration from the ancient Buddhist philosopher Nagarjuna. He takes us on an illuminating journey through the unknown, exploring the mysteries of the cosmos, the fabric of space and the nature of time. Carlo Rovelli is a theoretical physicist working mainly in the field of quantum gravity, who's also worked on the history and philosophy of science. He's the author of several best-selling books, including Reality is to What It Seems and Helgoland, to be published later this year. Priyamvada Natarajan is Professor of Astronomy and Physics at Yale University and the author of Mapping the Heavens, the radical scientific ideas that reveal the cosmos. In conversation with Natarajan, he takes us through the deeper meaning of the universe and our place in it. Carlo Rovelli is a renowned theoretical physicist who's worked on the foundations of loop quantum gravity. He's known for his worldwide bestsellers, 7 Brief Lessons on Physics and the Order of Time, which have been translated in more than 40 languages. Priyamvada Natarajan is a professor of astronomy and physics at Yale University, and her research is focused on understanding the nature of exotica in the universe, dark matter, dark energy and black holes. She is also the author of Mapping the Heavens, the radical scientific ideas that reveal the cosmos. Please do comment by typing it in the comment section. Ladies and gentlemen, of Nagarjuna, Sunyata and Stardust, Carlo Rovelli and Priyamvada Natarajan in conversation, presented in partnership with the University of York.
Really excited to have a conversation today with Carlo Rovelli, whose work and whose writing I have to confess I'm a great fan of. So welcome, Carlo, and I wish this was in Jaipur, but here we are.
Thank you very much, Priya. I'm very happy. Also, me too, I would much prefer doing this in India. I love when I'm in India. I have a special attachment to that country in particular. But this is good, and I'm very happy we're doing these things together.
Yeah. So so I think to jump off, I'm curious, right? So you've had a long-term sort of connection and visits to India. When was the first time you went to India?
In the 80s, in the mid 80s, I did not, many of my friends went to India in this wave of European sort of hippie kids. I did not do that, but got to India later because of a conference, in fact. There was a young scientist at the very beginning of loop quantum gravity, and there was a conference in Goa. So I went to Goa, and I remember my arrival in India. The difference, at the time, the difference between Europe and India was bigger than today. So for me, was quite a jump. And then I traveled. I decided to just forget about the conference after the conference and go around traveling, and I got in love with the people.
Oh, that's wonderful. Well, I think India and Italy have a lot in common. Our people are warm and pretty chaotic, right? Would you say
that's right?
Is that a fair description?
That's right. I sometimes say that it's a little bit it's a little bit like an Italian place, but with 1 billion people, which is
that's right. So I think I was intrigued that we have another connection in the sense that your theory of loop quantum gravity was actually developed when you were at Yale. So I'm curious to hear a little bit about the sort of the excitement when you came up with the idea, because I would like to have you explain, of course, the nature of quantum mechanics. Just very small asks, Carlo. Just the nature of quantum mechanics and and quantum loop gravity, and and you know, the connections, and what about these subjects kind of brought you to look at Buddhist philosophy as a way of interpreting and making meaning and understanding these rather complex concepts?
Yes. I remember my time in Yale. Let me start from your first question. It was I was in my late 20s, early 30s, I guess. And it was a wonderful moment. I made a wonderful friend, Lee Smolin, who was working in Yale. So I visited him. We became friends, and we got extremely excited because we found some little technical step that allowed us to start what is called today loop quantum gravity, which is an attempt to bring quantum mechanics and relativity together. Your work, Priya, is all in the big structure of the universe, and is largely dominated by Einstein ideas, by general relativity, and that's a foundation of our current understanding of the world. But there is the other half, which is quantum mechanics, of course. And my work is, most of my work has been in the attempt to bring the two together. And the theory we developed with Lee Smolin at the time, it's a quantum theory of general relativity, quantum theory of gravity, and that's what loop quantum gravity is. And in a few words, I would say quantum mechanics tell us three things. Two are relatively easy, and one is mysterious.
And these, Carlo, are things you do bring up in your book, Helgoland, right? So I just wanted to plug the book as well, because in Helgoland, you're really trying to elucidate sort of what is really at the heart of quantum mechanics.
Yes, because quantum mechanics it's a mysterious theory. It's an extraordinarily successful theory, which is at the basis of our understanding of matter, and which is used to do computers, to do nuclear powers, to understand how the sun works, all sorts of things, the colors works. So it's the basis of our physics, but it's strange, and there are aspects which are not clear. And if I had to try to capture it in a nutshell, I would say it's three things. One is that it tells us that there's some granularity. Things in the small are like grains, like quanta. For instance, light is made by photons, and photons are like particles of light. And loop quantum gravity, it's application of this to space and time. So the main result of loop quantum gravity is that the space in which we live is granular. Is made by quanta of space. So it's not continuous. We don't live in this continuous space which we learn at school, but rather in a space which is made by little grains, which are not immersed. These grains don't move in space, they are space themselves. And that's, well, sort of comprehensible. Okay, I mean, if you go into small, like, you know, a piece of matter is made by atoms, space is made by quantum space, light is made by photons, it's all granular. The second thing is probability. We know that things in the small move sort of randomly, and we know they're probabilistic. But there's a third aspect of quantum mechanics, the mysterious one, because quantum mechanics is a theory that tells us not what happens, but what we're going to see. It never tells us exactly what is going on. It tells us, if you do that, this is what you're going to see. And in between, it doesn't tell us what happens. And if you try to fill in what happened in between, it sort of doesn't work. So it seems that it's not a theory about how things are, but a theory about what we see, the result of our observation. And the way it's formulated, it brings the observer there. When you study in physics books, it's always, well, the observer does that, it has a machine and apparatus and does that. And that's very strange, because what does nature know if we're observing or not? I mean, we think that nature is itself. I mean, you study galaxies, right, and you study what happened. There are no observers that we, no, well, maybe there are, but we're not, it's not because there are observers that are on Andromeda, there is something happening. So the mystery of quantum mechanics is still open, I think. And that's where my interest in Buddhism has, not in Buddhism, in some ideas developed in the context of ancient Buddhism thought have emerged.
Right. So I mean, I think a lot of why quantum mechanics was such a radical departure from classical physics was, as you rightly pointed out, sort of this probabilistic nature, away from sort of the deterministic view that classical physics really attunes our mind to, in terms of the measurements that we make and, our sensory understanding of the physical world, right? And I guess the other point, as you mentioned, is in classical physics, we have this notion of a real sort of separation between the observed and the observer. So the observer is this independent, objective person who is making a measurement on a system using an apparatus, as you pointed out. But in quantum mechanics, that kind of discontinuity sort of breaks down, right? So it's not clear because the observer impacts the outcome of the measurement. And I think for a lot of people, that is really what is so incredible about quantum mechanics. Wouldn't you say that that's one of the features that, and as you mentioned, this idea of quantization is not as difficult conceptually because we all learn about sort of the Bohr atom, and we know when we see macroscopic objects that they are made of atoms, and atoms are basically mostly empty space, right? So there's a little nucleus and there's sort of electrons. So all of that, I think we can all come to grips with quite easily. But I think the concept in quantum mechanics about the lack of, sort of the breakdown of determinism, and the fact that an observer observing can alter the very system that they are observing is really quite mind-boggling.
It is mind-boggling, absolutely, and I agree with you. That's a mystery, and the probability, the indeterminism, it's very much connected to this need of talking about the observer, because quantum mechanics does not tell what is going on. It tells what is the observer going to see at the next interaction with the system. So it only tells us about the result of the interaction between the system and observer.
Right.
And in between, we don't know. And if we try to make a story in between, we get all sort of confusion and contradiction. It doesn't seem to work.
Yeah.
And I think, there is an open discussion. This has been discussed in Department of Philosophy, in Department of Physics. There is no really consensus about this, how to think about quantum mechanics. Everybody knows how to use quantum mechanics.
Mm-hmm.
And if you study it, you learn and you know how to use the quantum mechanics. So engineering uses, astrophysicists use it, chemists use it, and you do a calculation and then you make a measurement and it matches, the prediction match. But if you are asking what the theory is telling us about the world, it is telling us that the world is not the way we thought. It's not just a bunch of particles moving around in space with forces. It's much more complicated than that. Far more complicated than that. Far more strange than that. That's beautiful for me.
Right. And I guess, so this is where Nagarjuna and his Mula Madhya Makakarika comes in, his notion of emptiness. And so, I was curious because, in the 80s, there was a lot of excitement with particle physicists trying to kind of do these analogies with sort of Eastern mysticism. But I think, what you're doing is completely different, both in the order of time and in Helgoland. And I was curious, what about Nagarjuna's sort of conceptual understanding captured you?
Yeah, let me add something before answering this question. I strongly believe. I've worked on the history of physics and the philosophy of physics, and I strongly believe that science does not develop in isolation. If you look at the history of science and what has been achieved by many people, or if you look at the great results of Einstein, Maxwell, Newton, the ideas on which they built came from around themselves, from the philosophical, the general cultural world in which they were immersed. And vice versa, when they came up with their successful results, this influenced enormously the culture at large.
Yeah, I totally concur. I mean, I actually believe that, there is this concept of the extended mind and the extended ecosystem. So, ideas have very long legacies and people have been thinking about them. And it just so happens that, you have a brilliant individual who comes along who is able to synthesize in a completely
Yeah,
unprecedented way. And
yeah,
I really, I think we were mentioning this in the green room just beforehand, that I don't really buy this sort of trope of the lone scientific genius, which is kind of all wrapped up in this narrative of how we talk about how discoveries happen and so on. And like you, I do think that there is a long legacy, and that the person is really just the vessel
yeah.
for idea.
It's a vessel that moves and that brings in ideas that come from different parts, and is the results are not the result of a single man or a single woman, but they're not also the result of a single discipline, because
That's
a
right.
single discipline is influence, or a single culture, because cultures are constantly influenced. And I think what makes this entire machine of knowledge of culture go ahead is exactly the exchanges, the curiosity, the going out. What makes things go ahead is when the more we look far away, the more we learn ideas that help us to better understand and to get a better understanding. This has always happened. So my interest in Nagarjuna is not a strange thing that comes out of the blue. It's the same kind of so many scientists. I mean, Schrödinger was interested in the Vedanta, and Western philosophy was constantly influenced by Eastern philosophy, and vice versa. I mean, Indian thinkers have been influenced by in various periods of time by Mediterranean thinking, or so it's a back and forth. Now,
I think the globalization and the transfer of intellectual ideas goes well beyond sort of the capitalist ideas of materials and goods, right? Knowledge has been kind of crossing boundaries for a very long time.
knowledge has been crossing boundaries since a very long time, and it has uh, it has grown because we cross boundaries, because ideas cross boundaries. This is what makes things. So the most silly thing we can do, I think, is just focus on our own intellectual world, our own country, our own way of thinking, right? The more we look out, the more we get good ideas. So that's the background in which and I've always been very curious all my life. I mean, I'm a scientist, I'm a physicist, that's my specialty, but I've been reading about philosophy since ever. I've been reading about ideas from elsewhere since ever. But Nagarjuna, it's a recent discovery for me, very recent. I mean, just a few years ago. So in fact, I've recently been writing a book on trying to make sense of the quantum evolution. I've been thinking about quantum mechanics for long. I've been starting writing in the 90s about how to think about quantum mechanics. And I had this idea, it was hard to focus for me, that the core of quantum mechanics, the core idea, is not that there are observers, is that there are relations between things. So it's not that there is an atom and the scientist that observes. There's an atom and something else. And what the theory is about is how an atom manifests itself to something else, and how the something else manifests itself to something else. So the core, it seems to me that quantum mechanics is saying is that things exist because of their interaction with other things, in relation to other things, depending on other things. And then I had a number of people who, I was talking about that, said, have you read Nagarjuna? And I didn't, precisely because of what you said. In the 80s, there was a lot of attempts to find similarities between Eastern and specifically Indian mysticism ideas and modern science. It's interesting, it's a good effort, good books being written, but I never found it very convincing, because I found they were sort of more superficial analogies than deep connections. So I resisted that. But then at some point I decided, okay, I'm going to read Nagarjuna. And far from me to pretend that I understand it deeply, or that I understand everything one has to understand in Nagarjuna, because it's a great thinker, it's a major thinker that has been studied from all different points of view. But the point for me when you read something is not to understand exactly what is there. It's what you can do with ideas that you take there. And so I read it. I read it in an English translation by an analytic philosopher, American, Garfield. And it was a fantastic discovery for me. I mean, it was one of the beautiful intellectual journeys, one of the most beautiful intellectual journeys of the last years for me, because Nagarjuna has a way of telling us, look, you can't think at objects, at things, just as dependent on other things.
Right.
And once you realize that there is interdependency, you realize that the thing by itself is nothing at all. In his own words, is empty.
And it's
empty,
a completely sort of brand new way of describing reality.
Exactly. Exactly. It's a completely brand new way of describing reality, of thinking about reality. And it's not, Nagarjuna obviously didn't know anything about quantum mechanics. No, he could know anything. But he gives us instrument of things, way of thinking that are very helpful. Say, yeah, we can think that way. Yeah. That's the right way of thinking. It's the wrong way of thinking at the light of quantum mechanics is not, there is an object, a stone, there's another stone, and I have the properties of this, the property of this, the property of that. And then out of this, I say, well, they interact, they do things. No, that's the wrong way of thinking. The right way of thinking is that a stone is just the combination of the action that it does on anything else. And I can only understand it in terms of all what is around it.
Right.
And that's marvelous. And Nagarjuna in this is, I think, reading his book was a marvelous trip for me, and it clarified my idea. And I think now I have a cleaner understanding of how one could think the world at the light of quantum mechanics.
So, I mean, I think I'm also curious, right? In quantum mechanics, there are famously sort of two disparate sort of interpretations of quantum mechanics. So there's the many worlds interpretation. So there are these two sort of, they've been much debated. And I was curious if Nagarjuna's view, the frame that you get from his way of thinking about reality, does that allow you somehow to reconcile these two views, or does it help you gather sort of evidence for one being a more apt description than the other?
I think it helps me to find one view more convincing, but I believe that it's not that one view of quantum mechanics is right, another one is wrong.
Right.
Feynman said at some point that a good physicist knows different ways of thinking about the same phenomenon.
Right. And that, one view is convenient in certain circumstances, and for other problems, another view. And I think this is the kind of thing that we do all the time. So, in astrophysics, it's really strange. I often say that I work on the exotica of the universe, like black holes and dark matter, but not as exotic as the kinds of concepts and things that you work on, right? So here's a recalibration. But, there are times in which having modeling a system, a very complex system that you can't go and actually touch and do kind of controlled experiments on, like astrophysical objects, sometimes it's really useful to think of them as simple, like, map it onto a known problem, which we often do in physics, which we all joke about as like the spherical cow problem. So, simplifying things, right? And simplifying in different ways, depending on the particular problem that you are your question that is of interest. So I guess you're saying that these interpretations of quantum mechanics are also quite similar to that they are...
Yes, they're similar to that, because you can simplify in different manners, but you can also, there's also something more. you can make up things in your mind. Let me give you an example. We talk about heat, right? And today we understand heat very well. Heat is something is hot. This pen is hot because the molecules are moving very fast. So there is no such a thing like heat. Heat is not a thing. Okay, this is completely clear. It's digested.
Yeah.
However, if I have a hot pen and a cold pen, I could think that there is something which is heat, which is here and then is moving there, and I sort of visualize in my mind like a fluid moving. Am I making a mistake? No, I'm not making a mistake, provided that I keep in mind that it's a useful picture that is good up to a certain point. And
right,
not
it has limits. The explanatory power has limits, right?
Exactly. So there are a lot of notions which are good in a context, and we make a mistake only if we take them too seriously.
Right.
I can think that heat as a fluid, fine, perfectly fine. It's just that if I take it too seriously, I make mistake because after all, it's not a fluid; it's just molecules moving. And science is plenty of these things. So, in a sense, if I take Nagarjuna seriously, all notions are like that.
Right.
All notions are sort of provisional up to some point. And the most incredible chapter in the book of Nagarjuna is that he talks about this emptiness.
Yes.
Meaning a thing doesn't exist by itself. It doesn't have an independent, autonomous existence. It only exists independent of everything else.
I mean, am I right in thinking that it also, I mean, he's also referring to the fact that there isn't like an ultimate essence to anything.
There is no ultimate essence to anything. That's exactly the point. There's no essence in everything, because essence is what characterizes the thing ultimately, independently of what is around the situation. And
qualia, right? There are no qualia.
Exactly. There are no final point. And then so he calls this emptiness. So he says this is empty, this is empty, this is empty, this is a characteristic. And then he discusses space, he discusses time, he discusses causality, he discusses all the basic ideas we can try to use for one by one, and shows that they're all empty. Okay?
Right.
And then one is tempted to say, okay, I got to the bottom of understanding reality. The basic bottom of understanding reality is emptiness.
Right.
And then there is this absolutely marvelous chapter in Book of Nagarjuna. The title in the artificial title translation is "Emptiness is Empty."
Right.
In which he basically says, no, if you do that, you're making a mistake, because you're taking a concept that you're using for thinking about reality and taking it as autonomous, absolute, foundational for everything else. And that's a mistake. Right. So the various ways we use to think about reality, they're not wrong, they're right, but we shouldn't take them too seriously, because they're always depending on something else.
I guess one way for someone who is, interested in these philosophical questions as a person who reads and not working in analytic philosophy is, would you say that, one view that might be useful to hold, and I use the word useful, very deliberately, because it has limits and it's pertinent in some situations and not universal, is that reality is really multifaceted. It's like a multi-dimensional polygon, if you will. And
yes.
that you yes. want to view, some properties, some edges, some faces, then you have some useful tools that allow you to do that.
Yes.
And that, might you think yes. that's a sort of a useful analogy? That kind
very
of
very much so, because if you look at a lot of history of thinking, a lot of history of philosophy, in particular Western philosophy, but also in many strands of Eastern philosophy, the objective is to get to some absolute knowledge, some certainty, and some
truth.
The substance of everything, the final point on which you anchor everything. And if you think of the history of these attempts, if you look at them historically, what is surprising is that none of this ended up convincing everybody, right? Whether it's matter, whether it's spirit, where is God, whether it's my mind, the mind, whether it's structures, whether it's data of experience, whether it's reason. All the attempts to sort of found our knowledge and our understanding of the world on a single basic thing, they all turn out to be unconvincing. And one way of taking Nagarjuna is saying, but that's the wrong question.
Yeah.
I mean, forget the question of the foundations. That's not what we want. We want to understand reality, because Nagarjuna is not saying reality is all false and wrong and forget and you cannot understand it. No, not at all. He's saying reality is the chair, it's atoms. I mean, he wouldn't talk about it.
And it's comprehensible, right? It's
comprehensible. And we can understand more and more and more about it. And that's what we're doing. That's what you're doing when you study gravitational lenses and galaxies and so on. We're understanding reality. Or, in my opinion, that's what we're doing when we do literature. Because literature, a novel, a story gives us new ways for thinking about reality, new conceptual structure. Now, are the two things completely opposite? What we learn by reading Dostoevsky, or by reading the Ramayana, or by reading what we learn by studying general relativity, or by studying? No, they're not, because we are. And I don't think there are contradictions. There are things we don't understand in the connections. And it's very good to try to understand the connections between the different levels. We should try to bring all our knowledge to coherence, because in this effort, we understand it more. But as you say,
but I think while we attempt
multi-layered description of reality that we want.
And then while we attempt this kind of coherence, I think, as you rightly say, there, these disciplinary boundaries are kind of artificial in many ways, right? I mean, but sometimes there may be ways in which we may not be able to bring everything together and reduce them, and we may have to live with some ambiguity, right? And that's fine too. There's a lot of richness in that ambiguity, and in keeping one's mental frame open to ambiguity. I think that, often I find that when I'm thinking and I'm working on problems and I'm struggling with something, because, as you know, like part of the challenge in doing sort of cutting edge scientific research is, framing the problem, making the question such that you can answer it with the tools that you have is half the problem. And sometimes you are struggling to even find the framing. And occasionally you have to give up ways of thinking that you thought might work, because they are not going to address the right question, or a question that you can actually attempt with the ways that you have, the toolbox that you have. So I'm curious in terms of loop quantum gravity. Has sort of this conception of quantum mechanics been particularly helpful for you to develop? I just want to mention to all our listeners that, this integrating quantum mechanics and the theory of gravitation, sort of the micro with the macro, has been a dream for a very long time. And it's a dream that many sort of great minds have attempted and haven't quite succeeded, right? I mean, Einstein was working till the end of his life trying to do this sort of marriage of the small. So I was curious, how does Nagarjuna's, in closing, how does this sort of, these conceptual ways of thinking, have they helped you in this sort of, it's a grand and ambitious program, Quantum Loop Gravity? How helpful have they?
Yes, they have. And the philosophical thinking in general have. Because quantum gravity, it's the quantum theory of space and time itself. So what you cannot do in quantum gravity is to think, okay, this is space, is there, is fixed, is given. And then on space, I have, quantum system that interact. There is a quantum system here in space and somewhere else in space. which is a very convenient and easy way to think about the world. It's like putting a big canvas there in space, and then time passes. And in relativity, maybe it's a little bit more elastic because the canvas move, because time and space are a little bit mixed, but you still have space and time there. In quantum gravity, you do not, because quantum aspect of space make space itself that you cannot say where it is. It is sort of fuzzy, like quantum things are fuzzy. The theory tells you only when you interact with space what happened, but where are you to interact? So there's a big confusion.
Right.
And I think that
to say nothing of the way in which time gets entangled, right?
Time is even worse. In fact, one of my books is entirely devoted to the unraveling the nature of time. And I think the mistakes we do when we when your point, Priya, about the questions, it's key. When I give a thesis to a student, I usually give a student a problem, and then 3 years later, he had written the thesis and various papers and done a lot of work, but that problem was wrong. He hasn't solved that problem because it was wrongly formulated.
Right.
So very often the work in science, as you were saying, very beautiful, is not to answer sometimes, yes. I mean, you answer well-posed problem, but problems very often don't need to be answered, need to be discover that it was a wrong problem. That's not the right question. It's another question that you have answered. I mean, it's always been like that. I mean, one of the greatest discoveries when Kepler, after centuries of the problem of astronomy, was find the right combination of circles to explain the motion of the star. And it has been almost like that. Copernicus also been right. Combination of circles. And Kepler said, well, that's a wrong problem. I forget the circles. It's an ellipsis. It seems completely easy after.
Right.
After. But, when the problem you had was to find the right combination of circles, the idea to forget the problem, find a different problem, it's very hard. And so...
But I guess that's where, creativity in science rests, right? A lot of people fail to understand when we say that, science is a creative endeavor, very much like art and like writing and so on. So I think we need to wrap up. So I just want to recommend Carlo's latest book. I've loved reading Helgoland, and of course in order of time. So in closing, Carlo, what would you, is there anything that you would like to say just to close out our conversation?
Just one thing. I mean, I think it's wonderful that we have a conversation like that. And, I talk with you and I learn something from you. I read your book, I learn something from what you write. I read Nagarjuna and I learn something new. I think this is the beauty of the intellectual enterprise, these dialogues, these exchanges.
Yeah. Thank you so much, Carlo, for also sharing the joys of the life of mind that we both have the privilege of being able to read.
Thank you, Priya. Thank you very much.
Thank you, Carlo Rovelli and Priyamvada Natarajan, for that absolutely fascinating astral conversation. And thank you, University of York, for your support. We thank our celebration partner, Diageo. Thank you all for watching and being such a great audience. Do stay logged on to continue to watch with us the series of exciting sessions featuring a stellar list of speakers that have been specially curated for you. As you're aware, the cultural sector has been critically impacted by the pandemic, and while we have braced ourselves to embrace the new normal, we've struggled to ensure that we can continue to bring you a free flow of knowledge and ideas. We would love for you to support us at Teamwork Arts. Any contribution is welcome and would help spread knowledge and ideas seamlessly against all odds. Please do tweet using hashtag Jaipur Literature Festival 2021, and our social media handle is @JaipurLitFest. The festival is protected by Dettol. Hope to see you in the next session.